Hi guys, in this video we are going to solve this problem, sum of divisors. So here we are given this function sigma n, which denotes the sum of divisors of an integer n. So for 12, if we see these many divisors are there for 12, and if we add them, then we get 28. Now our task is to calculate this sum, which is summation from I equal to 1 to n for this sigma I, and take modulo with 10 to the power 9 plus 7, and n can be up to 10 to the power 12 here. Okay, so now let's see how we can solve this problem. So let's take n equal to 5 and see how we can solve this problem. So 1 2 3 4 5. Okay, so for 1, if you see, like only 1 is there for 1 as its divisor. For 2, if you see, like 1 and 2 are its divisor. For 3, 1 and 3 are its divisor. And for 4, 1 2 and 4 are its divisor. And for 5, 1 and 5 are its divisor. So now we have to sum all of them. So like 1 is coming 5 times, and 2 is coming 2 times, and 3 4 5, these are coming one time only. Now if we sum these, then we will get 21. So 5 4 3 4 5, so this comes out to be 21. Okay, and now this 5 here is in how many numbers 1 is a divisor. So if we see for these many numbers, 1 is a divisor, and if we see for this 2, so like this is like 2 is coming in 2 numbers, so 2 or 4, like it is a divisor for 2 numbers. And similarly for 3 4 5, like they are divisor of 1 and like 1 numbers. Okay, so like instead of just calculating like for every number its divisor and summing them, we can also do like this. So we can say for 1 we will see how many numbers are divisor of 1. So this we can easily do, like we can just take n by 1 and integer part of n by 1, and we can say okay, for n by 1 numbers, like 1 will be a divisor. Now for 2, we can say for n by 2 numbers, n will be a divisor. And when I am writing this in bracket, so this means like integer part of this only. And for 3, we can say okay, n by 3. So we can do it up to n, so n into n by n. Okay, now if we like replace this n with 5, then we will get this same equation. Okay, but still it is order of n time only, because we have to calculate this and we are going up to n. So what we can do is, like we have to improve it. Okay, basically. So now let's see how we can improve it. So for 1, we are having this n by 1 like multiples. So if we write like for 1, which are those multiples, and let's check n equal to 16. So if we take n equal to 16, then for 1, if you write these are these multiples, like 1 2 3 4 and up to 16 we are going. Okay, now what earlier we were doing, we were just saying like 1 is coming 16 times, or like 1 is a divisor of 16 numbers. So you are saying like 16 numbers into 1. Okay, then we were saying like for 2, like there are 8 multiples, like we can say just say like 16 by 2, integer part of this, and then we can just multiply it by 2. Okay, but this will get time out. So now let's improve a bit further. Okay, so for 1, like these many multiples are there. Okay, so this is like basically 1 will come 16 times. Okay, so in this answer variable which we have to return, we can store this 1 as 16 times, like we can add this 1 16 times. Okay, now if we divide these numbers by 1, okay, if we divide these numbers by 1, then we will get like 1 2 3 4, like same we will get, because we are dividing by 1. Okay, but if we divide these numbers by 1, then we get some additional information, and that additional information is like for this number 2, not only 1 is a divisor, but also this 2 is a divisor. Similarly for this 3, this 1 is a divisor, but also this 3 also is a divisor. And if you see, for every number we were just adding this 1, because it was a divisor of this number, like 3 4 5. Now for these numbers we will also add these number as well, this 2 3 4, because they are also its divisor. Okay, now if you see for this one, like this is like 1 is divisor of 1, and same thing here we are facing like 1 is divisor of 1. So this thing we have already handled here, so we are not going to duplicate it. So only this part we are going to add here. So we can say from 2 3 4 up to 16 we can add. So they are also these numbers divisor. Okay, now let's take 2, and this time it will become clear like why we are doing this, right? Okay, so for 2 if you write all its multiples or the numbers for which 2 is a divisor, then it is like this: 2 4 6 8 10 12 14 and 16. So these are the numbers for which 2 is a divisor. And if we divide these numbers by 2, so we get like something like this: 1 2 3 4 5 6 7 and 8. Okay, now if you see, so 2 is a divisor of 2. Okay, but this thing we already handled here, like we said 2 is a divisor of 2, so that's why we added this 2 here. Okay, so this we are not going to add again. Okay, now this 2 is a divisor of 4, so this we have not added yet. So these one numbers are there for which 2 is a divisor, so 2 is coming like 7 times. Okay, okay, so 2 is coming like 2 plus 2 plus 2, we can say it is coming 7 times. Okay, and when we divide these numbers by 2, then we get like 1 2 3 4 5. Okay, 7 8 up to 7 8. Now for this one if you see, so now 1 as a divisor of 2, like this thing we already handled when we were doing for 1. So we said 1 is a divisor of 2, so we added it here. Okay, similarly for this 2, not similarly, but okay, but for this 2, like we see, so 2 is a divisor of 4. Okay, but this thing we like already added here, like we said 2 is a divisor of 4. So not this, yes, this one only, sorry. So this we have already added here, 2 as a divisor of 4, so this we are not going to add again. Okay, now only this part is left. So 3 is a divisor of 6, we have not yet counted. So and 4 5 this also, so 3 4 5 and up to 8 we can add. Okay, now let's see for 3 also, so this becomes more clear. So for 3 if you see, like we are having 3 6 9 12 and 15. So these are the numbers for which 3 is a divisor. Okay, now 3 as a divisor of 3, this we already handled when we were doing for 1. So we said like 3 is a divisor of 3, so we added it. Okay, so if you see here, like we said 3 is a divisor of 3, so we added it here, like here. Okay, so this we are not going to repeat again. Similarly for this 6, if you say, like we said 3 is a divisor of 6, so this we already did, like when we were doing this part. So we said 3 is a divisor of 6, so we already added. And for this one 9, so 3 is as a divisor of 9, this we have not yet counted. So we can say okay, 3 numbers are there for which 3 is a divisor, so 3 numbers we can write, 3 plus 3 plus 3. Okay, not 3 numbers, like 3 times this 3 we can write in this divisor sum. Okay, and when we divide these numbers by 3, then we get like 1 2 3 4 and 5. Okay, so now 1 as a divisor of 3 we have already handled when we are doing for 1. 2 as a divisor of 6 we already handled when we are doing for 2. So like we said, like 2 is a divisor of 6 here. Okay, so now we are left with this part only, but this like 3 is a divisor of 9, like this we have handled here only in this step. So 3 is a divisor of 9, we have already handled here. So basically we have to just calculate this part only, or take into account this part only. So 4 and 5, so this 4 and 5 we can add. Okay, so if you have got the idea, then we can generalize it basically. So basically what we are having, like for any number x, we can say like if for this x, these are its multiples x, then we are having 2x 3x, and then we are going up to x minus 1 into x, then x square, then x into x plus 1, and then up to n by x, it is a part of it, and into x. Okay, so like this we are going. Okay, so now if you see like this part, we don't need to calculate again at this step for when we are doing for x. Why? Because this is getting carried by when we are doing like from 1 to x minus 1. Okay, so only this part starting from x square we have to take into account or calculate. Okay, so basically for every number x we have to start from x square only. Okay, so now in our case at most like we can go till x equal to 10 to the power 6, because this will make x square 10 to the power 12, and our number is up to 10 to the power 12 only. Okay, so we can say like in square root of n time we can do this part, like we have to run this loop only square root of n time. Okay, now but how do we calculate this thing in efficient time? So okay, so if we see this, then only in this part we are interested. Okay, so I will write it again. Okay, so okay, I will clear it a bit. Okay, so like we are having these numbers x2 x3x. Okay, and these many numbers are there which are multiples of 1, so we can say n by x numbers are there which are multiples of 1. Okay, and only this part we are interested in. Okay, so these many numbers we will just subtract. So these are like x minus 1 into x by x, these many numbers. So basically we are left with this one, n by x minus x plus 1. So these many numbers are there which are multiples of x, and those we have not taken care yet. And then this we can multiply by x and we will get our divisor sum. Okay, and we will add this to our divisor sum variable. And for this, and when we divide by x, then we get like 1 2 3, and then x minus 1 x, then x plus 1 x plus 2 up to n by x. So for this we are interested in this part only. Okay, so this like we can easily do because it is like natural sum from x plus 1 to n by x. So we can just take natural sum up to n by x. Okay, and then we can subtract natural sum up to x. So we can subtract natural sum up to x, and thus we will get our answer. Okay, so I hope it was clear. And now let's see how we can write code for this. So first we can just take an input. So okay, then I will declare a variable sum where I will store divisor sum. Then we will run this for loop from 1 to up to square root of n. Then I will take a variable count, which will be n by x minus x plus 1, as we discussed. Now in the sum we will add this, so sum plus equal to, we can say count and take modulo, and then we can multiply it by x. Okay, and x as it will be like square root of n, at most it will be like 10 to the power 6, so no need to take modulo for that. And after that we can again take modulo for this sum. Now we need to do like this, sum plus equal to natural sum. So for n by x we have to do, then we have to subtract natural sum up to x. Then now this sum can become negative, so we will add more to it and we will take again modulo. Now we will just write this function natural sum. So it will take argument as n. So for this we can just return n into n plus 1 by 2, but as n is up to 10 to the power 12, so this will overflow the long range. So what we are going to do is we are going to declare two variables, a and b. So if n is odd, then a will be n and b will become n plus 1 by 2, else this a will become n by 2 because n is even, so we can just divide it by 2, and b will become n plus 1. Now we can just multiply this and take the modulo, so we can just take a modulo mod and multiply it by b modulo mod and take modulo. Okay, now we can just see out this sum. Now for n equal to 5 we should get 21. Yes, we are getting 21. So now let's submit it. Yes, we are getting correct answer. So in next video we are going to solve this problem divisor analysis, and in this video, like if you had any problem in understanding the solution, then you can ask in comment section. And thank you guys for watching this video.